last time the problem equation demeyeyim de the problem hangi problem? So UTT is equal to C squared UXX for X between 0 and L and T from minus infinity to plus infinity with boundary conditions and initial condition. İsterseniz şöyle diyeyim. This is PDE. This is the boundary condition and this is the initial condition. So initial condition is UX0 equals f of x and u sub t. So this is the initial velocity g of x can have at most one solution, right? So today we will talk about existence of solutions and we will find the solutions. The first case we will consider the infinite string problem. Okay. So consider the problem, initial value problem. Since it is an infinite string, it doesn't have any boundary. Okay, it goes from minus infinity to plus infinity. So the equation is UTT is equal to C squared UXX, where X is between plus minus infinity and T is positive. And then we have this. This is initial position or initial displacement. And we have u sub t x0 equals g of x, initial velocity. So here we have a wave, and this wave, goes from minus infinity to plus infinity. Okay. At any x and time, so we don't draw the t-axis. So this is just u, x, and t. Depending on t, this wave, of course, changes. Okay, so this is the picture of the t at some, specific t. This is the picture of the wave u at a fixed time. As t changes, the graph will change, of course. Okay, but there is no boundaries for x, so That's an infinite wave. Okay, now how do we solve this? Okay, step one. So how to solve? Well, we do it in steps. Step one is transform or find its canonical form. Aslında hani canonical formunu bunun aslında bulmuştuk değil mi? Neydi? X şöyleydi. Daha önce yaptık sanki. Şuydu. Let t equals x plus ct and new x minus ct değil mi? Şöyleydi. Then u sub x is just u sub c, c sub x plus u sub new sub x. So it is just u c plus u new, right? Because both functions have derivative 1 with respect to x. U sub t is just u sub c, and then I have c here plus or minus c times u sub new, and u sub xx u sub xx, if you take derivative one more time with respect to x, so you will have xc bundan 2 tane gelecek değil mi? Ve şu tt'ye gelince bu ise şöyle olacak. Şurada bu c times u c minus u new'du. Bir daha türevini alırsanız bu sefer you will get the following: u c minus 2u c new plus u new. Yapalım. Evet. Ya mesela işte x'e göre bir daha türev alıyorum, right? When you take derivative with respect, evet. Evet. Bunun so derivative with respect to x, you will take derivative of this with respect to c, and then derivative of c with respect to x, which is 1. So you get u c, and then u c new, and then you take derivative of this u new c plus u new. But you have 2 of those. Evet, tabii ki, tabii ki. So here you have this c squared terms. So when you plug these, so u c squared uxx becomes what? This is just c squared u c minus 2u c new plus u new equals c squared times uxx, which is just u xc plus 2u c new plus u new. So this term will cancel with this one. This term will cancel with this one. So we get just 4c squared u c new equals 0. Or we get u c new equals 0. Right? That's the equation. How can we solve this? Well, so this is a function of two variables, and derivative with respect to c and nu is 0. So this implies what? So this thing, let's say this is just, so if I integrate with respect to c, I get a constant. But you see, I am integrating with respect to c. Therefore, I regard nu as a constant. Bir saniye. Ha, tamam. So we get this. Right? When you take derivative with respect to c, I get 0. So we regard functions of nu as constants with respect to the variable c. Okay, now I want to get u. Well, u is the integral of this with respect to nu, right? This time I integrate with respect to nu. So I have to take integral of this gadget with respect to nu. So it will be some function of nu plus a constant, but this time constant will be a function of c. So it is, let's say, a function of c. Okay. So a function whose mixed derivative c nu is 0 has to be of this form, where this thing is an antiderivative for this function. But it is another function, right? I mean, peki sonra ne olacak? Bu mu? Pay. Kötü çizmişim. Okey. Tahtaya bir tarafa mı bakıyordu? Bakmış mıydınız? Efendim? Şu anda burada da demin nasıldı? Demin burada mıydı? Hı? Tamam. Neyse şöyle bir daha göstermiş olayım da. Ne zaman çevirdiğimi hatırlamıyorum. Okey. Şimdi hı, eee, şu kısma step 2 diyeyim. So, step 2 is to solve this equation. And step 3 is the following. Step 3, transform to the original variables. Transform the solution to x and y. Bunu nasıl yapacağız? İşte so our solution u is a function of nu plus a function of c. Well, nu is one of them was minus, so x minus ct plus x plus ct. So this is the solution, okay? This is the general solution. So this is the general solution. But to find the solution of the initial value problem, we have to use the initial conditions. So let's do that. So step 4, apply the initial conditions. Okay. So what's the initial condition? U0 x0 is equal to f of x. So when I plug these, so we plug 0 for t, so we get phi x and psi x adds up to f, and then we have also the other condition, u sub t x0 equals g of x. Now what is u sub t? I have to take derivative of this with respect to t. So what is that? That is just derivative of this function, right? X minus ct, and then derivative of inside with respect to t, which is minus c, plus derivative of this function at x plus ct times derivative of inside with respect to t, which is just c, and that should be equal to g of x. So we get two equations in two unknowns, right? So this is a system of ordinary differential equations. Well, not really. This is not a differential equation, but this one is. Burada tabii t yerine 0 yazacağız. So we have to compute this at t equals 0. T equals 0. So we get what? This is at this point, and this point adds up to gx. Değil mi? Minus c. Ha pardon, şu evet. Şurada minus c var, şurada plus c var. Tamam. Bunu nasıl çözeriz? İntegral alacağız, değil mi? So when you integrate this with respect to x, so let's say from x0 to x, x0 to x, evet, ama bu tek değişkenli fonksiyon ya. These are one variable functions. Okay, so integral of this with respect to this gadget, so you will get what? Minus c. Bunun entire derivatifi nedir? Zaten işte şu nesne, değil mi? Bunun x'teki değeri eksi x0'daki değeri artı C çarpı bunun x'teki değeri eksi x sıfırdaki değeri eşittir g'nin değeri, yani onu isterseniz şöyle bırakmış, biz de öyle bırakalım, tau d tau. Integrating instead of x, of course we write a dummy variable, right? Let's say tau tau, and then d tau, and here we have tau d tau. Okay, so we get what? Let me rewrite. So this function plus this function adds up to f, and then I have minus c times minus x0 plus c times x0 equals integral from x0 to x g tau d tau. Okay, now we can solve this. Nasıl? Şöyle. Yani birini alıp diğerini yerine koyalım. Ha, şöyle bir şey. Şunlar constant ya. Bu constant'ların hepsini şuraya atalım. So let me write this minus c times phi x plus c times psi x equals x0 to x g tau d tau plus k. So k is what? K is just minus c times this number plus c times this number. You just take it to this side. So we have this equation and then this equation. Buradan da şöyle yazalım. This is just f of x minus psi of x. Okay, so if I just plug it here, so we get minus c times this. So minus c times f of x minus c times this. So it is just c times psi x plus another psi c times psi x. So I have 2 times this, and that is equal to integral from x0 to x g okay, g tau d tau plus k. So psi x is what? Okay, I can take this to the other side and divide by 2c. C's will be cancelled. So psi x is just f of x divided by 2 plus 1 over 2c x0 to x g tau d tau plus some constant. Constant nereye gitti? Bir dakika. Efendim? Ee, bunlar birbirini götürüyor mu acaba? Ee, x0'daki değerleri e, ama yok, niye götürsün ki onlar arbitrary function'lar. Onu anlamadım. Ee, yani bu k bölü 2c olması lazım. Burada da şu ise ne olacak? Ee, ikisinin toplamı f'ti. Dolayısıyla o zaman şöyle olur. So this is f of x over 2. This time it should be minus, right? So that when you add them up, they cancel out. X0 to x, g tau, b tau plus k over 2c. Hangisi? Ha, yani evet, minus olması lazım. Evet. Birbirini götürecek. Peki ondan sonra da şöyle bir üçkağıt var. Eee, so our solution is what? Our solution is u eee, xt is just, neyse bunu şuraya yazayım. Kaldırayım mı yukarıya? Okay, our solution uxt is what? Uxt is phi x minus ct plus psi x minus, no, x plus ct. Okay, so okay, all right. So I have uh, hmm. X yerine x eksi ct yazacağız. İkisinde de f var. Yani birinde x yerine x eksi ct, öbüründe x artı ct. Yani şu, o zaman f x minus ct over 2 or maybe I should just write f x plus ct over 2 plus 1 over 2c, çok yaşa. Şöyle. Şimdi x sıfırdan x'e integrali, çok yaşa. Tebeşir mi dokundu? Efendim? Olabilir. Şimdi x0'dan x'e ne olacak? Efendim? Neler gitmeyecek mi? Birinde şurada evet. Birinde x eksi ct'ye integral değil mi? G tau d tau. Öbüründe x0'dan x artı ct'ye integral. Ha, şu mu? Okey. Ondan sonra da toplayınca k'lar gitti. Okey. İyi. Okey. Burada da dikkat ederseniz bu nedir? So if I switch the boundaries, this sign will be plus. So let me make plus, and this is x minus ct, and this becomes x0. So we have integral from x minus c2 to x0 of this gadget plus integral from x0 to this. So it will add up to 1 over 2 times. So this is f minus ct plus f plus ct plus 1 over 2c integral from x minus ct to x plus ct g tau d tau. Okay, so that's the general solution. Oops. So u is the sum of these two. We just plug the values. K's are gone, and we had here x0 to x minus ct, and this is minus. And we make this plus and change the boundaries x minus ct to x0. And then we add up these two integrals as a single integral, because this is from x minus c2 to x0, and this is from x0 to x plus ct. So that's the solution. Okay. Now, this is known as D'Alembert's solution. This is known as D'Alembert solution to the equation. Initial value problem. Okay. Şurada bir remark var. Remark. First remark is the value u x0 t0 So at some fixed point u0, x0, t0 depends only on the values of g in the interval x0 minus tc, x0 plus tc, and the values of f at the endpoints of this interval. Değil mi? So at any point x0, t0, so this value is determined by the, so we have this interval x0 minus t c0, x0 plus t c0, and we have the wave, okay, let's say like this on this interval. Okay, so here, so this value is determined by the values of f at the end points of this interval, and by the values of the velocity function in the interval, not just the endpoints, but the whole interval. Yani bir yerde so yani so at some point x0, the value of u at this point, and of course at t0, so you need to look at, so x0 is somewhere here, right? You go this much from this point and this much from this point, and pardon, şu tabii t0c. Yani x sıfırın etrafında şöyle bir interval'a bakıyorsunuz. Orası belirliyor. Dolayısıyla hani, so the values of f and g outside this interval doesn't affect u x0 t0. Değil mi? İlginç bir şey. Yani dalganın diğer kısımları oradaki değerini etkilemiyor bir yerde. Veya initial condition'ların değeri şeyi etkilemiyor. Odd, respectively even, f g of x. So if this initial data are odd or even, then uxt is odd, respectively even. Şuna if diyelim. Ya da yield diyeyim şöyle. Yani F ile G oddsa bu da odd. F ile G even'sa solution da even. Neden? Okay, UXT is just 1/2 times Fx minus Ct Fx plus Ct plus 1/2 x minus Ct x plus Ct and Gx minus G tau. Okay. Her şeyi mesela şeyle şey yapalım. Assume F and G are odd. O zaman bakalım U nasıl olacak? Minus x minus t koyduğum zaman değil mi? Burada so we put minus x minus t. So the expression here is just multiply with minus 1. But f is an odd function, so that minus sign goes out. And the same thing here. The minus sign goes out. So we get minus 1/2 times f of x minus ct plus f x plus ct. Değil mi? Eksi eksi koyarsak eksi işareti dışarı çıkacak. Burada da dışarı çıkacak. So we have minus. And then I have 1/2 times. Here I put minus sign. So when I put minus sign for x and t, we get minus x plus ct minus x minus ct. Bir dakika. Evet, böyle oldu. Şimdi tau'yu let's replace tau with, let's say, with minus tau. Then what happens? This is tau, right? Tau from this value to this value. If I replace tau with minus tau, then this will be from x minus ct to x plus ct. But we replace both tau and minus tau with minus 1. So I put minus sign here and minus sign here. This minus sign goes out. This minus sign goes out. Two minus signs becomes plus. So nothing changes. No, it should change. Bir dakika. Bir dakika. İkisi de eksiye döndü. Bir dakika. Şöyle yapayım. İyi, bunu şeyden sonra yapalım. Okay, let's give break. After the break I'll do this.